All right, boys and girls, welcome back to the drive-through for Stressed Out Remix.
Yeah.
We're here in the fourth quarter. We are in data analysis. I've never taught this before. There's no teacher's manual, so I'm literally making this up. So you need to fact-check it, okay? Data analysis is how do we look at big sets of data. It's like the most important thing I could probably teach you in today's world. It's how you judge whether or not it's fake news or real news. Ironically, this is a fake lecture, so this is all together, okay? These are like different words that you're going to see throughout this chapter, even throughout this section here, okay? A histogram measures like the frequency that something happens. And then like the number, let's say we're doing number of home runs in a season. So over here there'd be like 5 home runs, 10 home runs, 15, 20, 25, 30, 35, 40. We'll just cap it at 40 for this particular season. And then here, sorry, no, this is the number of people that did that. The number of people that got that many home runs in a baseball season. And then here would be the number of home runs. So similarly, 5, 10, 15, 20, 25, 30, 35, 40. So how many people hit between 0 and 5 runs in the major leagues? Let's just say 15 people did. Let's say we're looking at the National League West. Whatever. How many people hit between 5 and 10 home runs? Slightly more. How many, I'm making this data up, how many people hit between 10 and 15 home runs? More than that. How many people hit between 20 and 24 home runs? Well, that's a really popular number. And then maybe it starts to decrease and looks something like this. And maybe a very few people in the National League West hit between 35 and 40 home runs, okay? This would be how data is typically seen. This is pretty normal. Maybe you've heard of a bell-shaped curve, okay? That's how grades are supposed to be curved. It just means that most of the data is in the middle, and then there's some extremes. That's what a bell-shaped curve means. Now, this particular curve has more data to the left than it does to the right. And so this would be skewed right. It's unimodal. What's unicorn? What's a unicorn? It's got one horn. What's a unicycle?
Got one wheel.
So unimodal means most of the high point of the data is contained in one big spike, okay? We'll address bimodal later. So that's a histogram. A box and whisker plot looks like this. You got a number line. Above it, you've got a box with a median. And then you got whiskers. This number right here represents the absolute middle number of the data. This represents the first quartile of data. So the lowest 25% of people score there. This would be your second quartile. So between the 25th and the 49th percentile of people are there. This right here is your median again. That number right here, that's an important number. It splits the data in half. This right here would be your third quartile. So if you're in that, you're better than 50% of the population, but you're worse than the upper quartile. And this is the top-notch folks. This would be your fourth quartile or your upper quartile, and that's where the cream of the crop live. Okay? Median, that is your middle number. Mean, that is your average number. Mode, that is your number that appears the most. And the range is the biggest score minus the smallest score. It's the total range. The quartiles I talked about. What's the root of the word quartile? quart, which is 4. So it spreads all of the data into 4 sets. If you are in the 25th percent or the first quartile, are you great at something or poor at something? You're pretty bad at something. Okay? And then the interquartile range is this. It's really where the typical data lies. Average people lie in the interquartile range. They are neither amazing nor bad. They're average. Okay? All right. And we don't stand for that. That's just not in our DNA.
Nah, we're in the most quartile.
We are. All right. So, now I want you to pause the video and read the situation. Rachel is trying to get some data on how many texts people send. Okay? They each ask 24 of their friends. Let's see. Is there 48 data points here? Yeah. Okay. So they each have asked, there's 48 responses. The book is really nice in this instance because they put it in order for us. So notice, someone sends 0 texts in a day. Someone else sends 275 texts in a day. What's our range?
275.
Our range is 275 texts. This shows you the histogram. So how many people send between 0 and 20 texts in a given day? 19 people. How many people send between 20 and 40 texts in a given day? 4 people. Well, you can kind of notice. You got this is an outlier. We're going to talk about what an outlier is. You basically got 2 groups of people. You got people that don't text very much, and you got people that text a fair amount.
So the socialists and the non-socialists.
Yeah. Or maybe this is the girl's friends, and this is the mom's friends. Like, doesn't that make more sense? The girl's friends probably text more often than the mom's friends do. This is a bimodal set of data. There are 2 different modes. Now, in that case, mode doesn't just represent the number that appears the most, but it shows that lots of the data is here and lots of the data is there. And when that happens, there's normally an explanation for it. We gave an explanation for that. What was my explanation for why that might have happened?
They're teenagers.
Maybe this is the teenage group over here,
And
and then the old farts over here. Okay? All right. So, what conclusions might be made based on the histogram? Oh, there's infinitely many conclusions we can make, but we could say that in this set of data, people send between 0 and 280 texts in a given day. We can say that very, very, very few people send more than 180 texts in a given day. Okay? We can say that this is bimodal. Okay? I don't know what the median is, though. I don't know what the mean is. So in order to know some of that stuff, we have to represent the same data by creating a box plot. Okay? Above the histogram. So let me go back. I'm going to do the box plot right here. We have 48 numbers. So how many do I have to count, Carson, to find the mean? Or sorry, the median?
you gotta count them all.
Well, no, where's the median going to fall? There's 48 numbers.
In the middle.
In the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. After the 24th one comes the 25th one. That line should mean that there are an equal amount above and below.
Make the medium 75.
So the median would be 75. Very good. Okay? Now, what we need to do is cut each half in half to get quarters. So we just counted to what to get to the median? We counted to 24. So now let's count to 12. No! Let's count to 12 twice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And let's start at the end and count backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now we have our quartiles. Okay? So, our number line is going to go from 0 to 275. Okay? Let's see, halfway there. I made it a little less than half because I didn't feel like writing a decimal on my number line. Half of 275, half of 280 is 140. So let's just call this 130. Okay, let's cut that in half. 65. Let's add 65 to it. 235. Now we've just got some numbers on our number line. Look, our first box is going to start right here at 6. The median will exist at 70. I usually extend the median line because it's important. The third quartile will end where?
150.
All the way at 150. And then this whisker is significantly longer. Why is it significantly longer? Because of the outlier. Okay. So, that is a box and whisker plot. I'm going to have to kind of toggle from screen to screen. What does the story about the box plot tell? Well, the box plot tells us the median, it tells us the quartiles, and it tells us the interquartile range. It also indicates that we might have an outlier.
One thing it doesn't show is
It doesn't show that it's bimodal, so you wouldn't understand that maybe there's a group of teens and a group of old farts. And if you look at the box plot, the histogram, you can tell that. So it's just teaching you like everything else in math. There's like, do you do it by hand or do you do it by the graphing calculator? There's pros and cons. And it's best if you understand how to do it both ways. We want to be able to make histograms and box plots. So far, so good?
Yep.
All right, moving on. Now, prior to talking about the data with her mom, Rachel had created a box plot using her own data, and it looked quite different than our box plot. Oh, no, this is just Rachel's data. Sorry, just Rachel's data. So, notice, Rachel created a box plot. This is her quartile 1. This is her quartile 2, quartile 3, and quartile 4. Rachel didn't include outliers on her box and whisker plot. That's actually a better box and whisker plot than I made. So how did she do it? Well, she took her interquartile range. So I can't tell what that is. I'm going to guess it goes from 160 here to 140 maybe? How about 130? Okay? So what is her interquartile range? IQR. What is the range of the second? Excellent, Carson. It's 30. Now, ViewSonic. Just add to the stress, ViewSonic. Why don't you? Just pile on the stress. Now, if you take your interquartile range and you multiply by 1.5, that is the definition of an outlier. So, 45 above or below the interquartile range. So if this was 160, 160 plus 45 is, so that makes this 205. 130 minus 45 is, that would be 95. So what we calculated wrong was the 130, but don't worry about it. That's just how you find the interquartile range. That's how you find the outliers. The point being, these data points are outliers because they lie more than 1.5 interquartile ranges away from the interquartile. It's very confusing. Practice it. Ask me for help. Don't worry about it. Okay? That's how all these videos go. It'll make more sense once you practice. Do you agree?
Yes, sir.
All right. So describe the data that Rachel collected from her friends. Well, it seems to be very normal and very centered. It doesn't have nearly the spread that the data that included her mom's stuff had, right? It contains outliers.
A lot more.
It's got 4 outliers. One is Chatty Cathy over here. And then these are the people that don't text as much. Your high-level students, maybe. Okay? Compare the 2 box plots. It looks like the median is very close to the same. However, my interquartile range was huge. It went from 150 or so all the way down to 6. So my spread is wider. Give me a second here. So in general, they want us to compare the shape, the center, and the spread. I think the shape is more condensed. More of the data is right here in the middle. The center is the same, and the spread is actually condensed. It's narrower. Okay? Rachel wants to continue sending her normal number of texts, about 100, and her mom wants her to decrease that by half, 50. Present an argument for each side. Would you like to do this, or you want me to do it?
I'll do it.
Go ahead, Carson.
She should do half.
Well, so which argument are you trying to make? You're going to make an argument for the mom's case?
Yes.
Okay. Why should she do half?
Because she can be special.
Yeah, but that's not using any data.
Yeah.
You can't. That's just fake news.
Yeah, it is. So, based on real things, she should continue what she's doing, so she can stay in.
So how would she make an argument to her mom to continue what she was doing? She would say, Mom, she'd say, Mom, if I send 100 texts in a day, I am significantly below. In fact, I am an outlier compared to my peers. I send statistically significantly less text than my peers, which means I am a baller compared to my socially distracted, chatty peers. That'd be a great argument.
Yeah.
Okay? What would her mom's argument be? It would be, kiddo. You send 100 texts in a day. And according to the data that the 2 of us came up with on our own, you are in the top of the 3rd quartile. You are sending way more text than typical people do. And for that reason, I would like for you to cut it to 50, where you are somewhere in the 2nd quartile, in the normal range. Got it? This is how fake news happens. You can interpret data and say factual statements about it both ways. All right, I got to be out of time. Almost at 20. Shout out to Mrs. Wall for her patience. Boom!